Alright, so now let's talk about type of functions. So functions basically can be categorized into three different categories. So the first is going to be for the case of even function. So that is the first type. So the second type is called as the odd function. And the last one, so it is called as a neither function. So there are multiple ways of like pronouncing this. Some people pronounce this as neither, some people pronounce this as neither. So it's actually depend on your accent, but I'm used to pronouncing this as being neither. Alright, so we have two types of function that we're going to look at. So even, odd, and neither. So what is the easiest way to identify function? So that is going to be according to the shape. So let me show you three types of function. So let me sketch three functions and have a look. So which one is odd, which one is even, which one is neither. So we can simply identify that from the graph itself. So I'm going to have three of them. So that's my first axis, my second axis, and let's put the last one down here. Okay, let's see. This is going to be the first one. And let's see, the last one looks like this. Okay, so this is going to be three type of function that we can identify just based on the shape itself. Okay, so what happened is that these lines over here, so for each of the sketching we have two lines. So two lines referring to this one. So this is my first line and this is my second line. So those are what I see it as being two lines. Alright, so from the two lines here, which is separated by the axis, so this is my axis, so the two lines is separated by the axis right there. So we can basically identify whether this is going to be an even function, odd function, or neither function. So actually, so the first one over here, so this is an example of an even function. Okay, so that's going to be the first one. And the second one over here, so this is actually a shape of an odd function. And the last one here, this is an example of a neither function. So now let me give you the idea. So how do we tell whether a function is even, odd, or neither from the shape itself? As I mentioned to you just now, so all we have to do is, so we have to observe the two lines over here. So they are basically separated by the axis. So this is my axis. So this is what separates the two lines. Okay, so let's suppose that. So this is going to be my first line. So how do I get the other line on the side? All I have to do is I'm going to reflect that on the vertical axis. So remember, so the previous one here, this is called as the horizontal axis, and this is actually called as the vertical axis, right? I'm going to call it as general, not being y or whatever that is, because it could be different according to cases. Right, so how do I get like the other half of the graph? So all I have to do is I'm going to reflect on the axis right here. So imagine that this is going to be the mirror. So the idea that we're going to use right here is called as the reflection. So remember, we learned this before. So you must have seen this before in your previous study. I don't know whether it's going to be diploma or something. So this is like, there's the topic called as type of, like, not type of function. Like you learn about reflection, translation, and so on. Okay, so reflection is, the idea is that you have a mirror. Okay, for example, this is going to be my mirror. For example, let's say if I have this shape on the other side of the mirror, so that my image is going to be here. Okay, so it's going to be equally distanced between both of this, and it's going to be on the opposite. Or for example, let's say if I have a triangle here, automatically the image is going to be the same distance as well with a triangle. Or let's say, what else can I have? So let's say if I have a square somewhere over here, so of course the image is going to be equally distanced, so I'm going to have somewhere right there. So this is going to be the idea of what we're doing here as well. So if I were to reflect this line right here, so this is, let's say this is going to be my first line. So when I reflect this on the vertical axis, so it becomes the other line. So this is called as an even function, all right? So the most prominent feature of an even function is that they are side by side. And of course, so these two lines over here, they are symmetrical because they are an image of each other. So they are going to be the same, they are going to have the same length. right? So this length over here is going to be exactly the same length as the other one. But what you have to do, you just have to reflect that on the vertical axis. So that is going to be a feature of an even function. They're going to be side by side. Okay, then number 2 over here. So this is going to be an example of an odd function. So the feature is that, so you can have one at the top, and the other line is going to be at the bottom. So the other line that is separated by the axis, so will be at the bottom. So that is a characteristic of an odd function. Right, so remember, for the case of even function, so this is where your mirror is. This is where the reflection occurs. But for the case of odd function, so the reflection is going to occur on both axes. So it's going to occur on the vertical axis, and you also have to reflect that on the horizontal axis. So what do I mean by that? Okay, for example, let's say if I were to reflect this line over here, so let's say this is my this is my original line. So if I reflect that on the vertical axis, so this is how the reflection looks like. And then when I reflect that again on the horizontal axis, so this axis right here, then only I will get this line, the second line. Okay, so that is why for the case of odd function, so these two function, the two lines, how do we get the second line from the first line? You have to reflect that on both axes. So that is called, when you have something like this, so it is called as an odd function. Alright, so the prominent features is that, so one line is going to be at the top, one line is going to be at the bottom, and they are going to be separated by the axis. So both axes right here. Okay, so that is an example of an odd function. And neither function is a special one, and even in terms of the calculation, it's going to be more complicated than even an odd. So what happens is that when you have a neither function, it doesn't show any like characteristic of being even or odd. So let's prove here, it is not even and it is also not odd, then only we know that it's going to fall into the neither category. For example, let's say that if I would take this as my first line, if this is an even function, I know that if I will reflect that on the vertical axis, so the other line is supposed to look like this, but that is not the case for this one. Okay, because my line is this line right here, so therefore it definitely is not going to be even. So we rule out being even function. And if I say that this is going to be an odd function, so what happens is that if I were to reflect that, so when I reflect it for the first time on the vertical axis, so my line is going to look like this, and when I reflect that again on the horizontal axis, then the line is supposed to look like this. But that is not the case, because our line is at the top right there. So this is not even, and it is also not odd. Automatically it is going to fall under the neither category. Okay, so don't worry, later when I teach you how to sketch for periodic function, so we are going to identify for each of the cases whether it's going to be even, odd, or neither. So we're going to have a look at more examples on this. Okay, so basically if it's side by side, it's going to be even. Okay, that is characteristic of even function. If it's one at the top, one at the bottom, separated by the axis, so that is a characteristic of an odd function. So if it doesn't have both of the characteristic, so it is called as being a neither function. So that is how you identify them. Even and odd function are actually special. Why are they special? Because they have certain characteristics that can actually assist us in our calculation. Okay, let me put some definition and comparison between each of them. So let me put even on the side, and this is not right, and I'm going to write the characteristic of odd on the other side. Neither, so there's nothing special about neither. So when you have a neither function, the calculation is going to be super long, so there is no shortcut at all. So you have to do it the long way. But for even and odd, yes, that will be ways in order to simplify our calculation. Okay, let me write the definition first for the case of even function. So even function, as I mentioned just now, so they are symmetric about the vertical axis. Remember, the mirror, the reflection will be on the vertical axis. You cut it in the middle, it's going to look the same left and right mirror image of each other. So that is an even function. So let's prove here. So it reflects on vertical axis. Right? So for example, if I have some like this, so it's going to be even. Okay, I suppose this is going to be my graph. Okay, so it might not look even because of my drawing, but let's say it's going to be the same side by side. So this is going to be an example of an even function. Where's the mirror? The mirror is going to be here. So on the vertical axis. So when we reflect, it's going to be the mirror image of each other side by side. Okay, let's pick some values over here. So let's say it's going to be negative p because they are going to be symmetric. Automatically on this side, this is going to be a positive of p. So let's highlight this region because we're going to find this region later. Okay, and for the case of odd functions, the definition is that odd functions are functions that are symmetric about the origin. So that is how we call them. Symmetric about the origin. You know where the origin is. It's the point where we have 0, 0 on the axis. So that is the origin. I'm pretty sure you know that already. So what happened is that, so the first line is going to reflect on both axes, then only you will get the second line. So what is the difference when we have axes with an I and an E? So this is singular, this is plural. So that is the difference between them. One axis with an I, two axes with an E. Okay, so let me show you an example. So this is an example of an odd function. So as I mentioned to you before, so one is going to be at the top, the other one is going to be at the bottom. So that is the easiest way to identify them. Okay, so how do we identify so whether a function is even or odd? First, it's going to be from the sketching of the graph, or you can actually identify that from the function itself. So let me give you a couple of examples of even function. So among the most famous even function are going to be function t to the power of n. So when n is even. Okay, so now we're no longer using x, we're using t as our variable. So if you have like t squared previously, now it's going to, if you have x squared previously, now it's going to be x squared, it's going to be t squared, t cubed, t to the 4 and so on. Okay, and is an even number. Like, you know what is an even number, right? So even number are like numbers that are multiple of 2's. That 2, 4, 6 is called as nombor genap in Bahasa Melayu, in Malay. Okay, so any number that are multiple of 2's, so that is called as an even number. Okay, for example, so what are going to be the example? If I have t to the power of 2, t to the power of 4, t to the power of 50, so those are going to be an example of even function. As long as the power of the t is an even number, so it's going to be an even function. So that will be the opposite case for odd function. Okay, an example of odd function are the case of t to the power of n, but when n is an odd number. An odd number are the opposite. This number that is not the multiple of 2's. So in Malay it is called as nombor ganjil. So that is what it's called. Okay, for example, if I were to have some like t to the power of 1, t to the power of 3, t to the power of 7 and so on. So those are going to be an example of an odd function. Like if you sketch this graph, you would definitely notice that the function is going to have these features for which one area is going to be at the top, one area is going to be at the bottom. But for the case of even, so they are going to be side by side and the area are going to be symmetric. And there are going to be like trigonometric function as well, which are going to be example of even and odd function. And the most two important trigonometric function that we're going to come across in Chapter 4 is going to be cosine and sine functions. So you're going to come across this over and over again, so get used to it. Okay, so cosine function is an example of even function. So any cosine function, it doesn't like any, there are like certain special cases for which it's not going to be even, especially when we choose the domain. But on general, so almost all cosine functions are going to be even. Okay, so if you come across something like this in your calculation, so cos of t, so cos of 2 pi t and so on. Okay, so most probably like there is a very high chance that it is going to be a cosine function. Like most of the time it is going to be cosine unless we tamper with the domain. And oppositely, so sine functions are going to be categorized as being odd functions. So if you come across some like sine of pi over 2t in your calculation, or like just sine of t, as long as there is a sine function somewhere, automatically we know that this is going to fall into the odd function category. Okay, why is it fall into the even sine, cosine is even and sine is even? That is because of the shape itself. So let me sketch for you the cosine and the sine function, so you can actually determine for yourself. Okay, so this is how cosine function looks like. So it looks something like this. Okay, so this is going to be our axis. Now let me sketch the sine as well. Sine is going to look like this. And if we will look at the line that are separated by the axis, which is going to be this two right here, so this two, they are actually side by side, right? And they are, if I were to reflect that on this vertical axis, so they're going to be the mirror image of each other, so that is why they are going to be even. And for this case, on the other hand, for the sine function, so this is the line that are separated by the axis. If you notice, one is positioned at the top, one is positioned at the bottom, and I will get from the first line, so let's say this is the first line and this is going to be the second line, I will only get the second curve by reflecting the first curve twice, right? So I have to reflect it first on the, so let's say first I'm going to reflect that on the horizontal axis, so it's going to look like this, and reflect it again on the vertical axis, then only I will have the curve number 2. So which one you're going to start with, it doesn't matter whether you start by reflecting on vertical or whether you start by reflecting on the horizontal. So it's not a big deal, it's going to give you exactly the same answer, so whichever you start with. Okay, so based on this, we know that cosine is going to be even and sine is going to be odd function. Okay, so that is definition and example of even and odd function. So let's